Hello, here we are again, talking about polynomials even more intently than we have before. So in the last section, if you remember, we were multiplying polynomials, and we're doing it kind of the tedious, slow, painful way. As a matter of fact, it wasn't even just tedious and slower. It was even you're more likely to make mistakes. So it's like all the worst things in math in one. And then at the very end of the last section, we showed there's an easier way to multiply polynomials. In this section, it gives us even more tricks on how to multiply, but there's specific types of polynomials. They're not, I guess all these tricks, the things you're multiplying have to look a certain way. These tricks don't work for all kinds of polynomials. They have to be this certain type. So they're pretty good. It works, all the time. But it's kind of up to you if you want to memorize these and use them, or if you say, just use the method that we learned at the end of the last section, because it works, and I have a bad memory, so there's already too much for me to memorize here. Alright, so let's see. I think for each of these methods, what we're going to do is try an example first to try to build up to the method. So let's just start, go right ahead and look at example 1 here. And this section is called special products because we're saying, if you're multiplying these special types of polynomials, there's a faster way to do it. So it's only for these special ones, though. But let's see. Here in example 1, we have two binomials multiplied together. Notice you have an x and a 6 here. That's 2 terms. And an x and a 5 here. That's 2 terms. But let's kind of practice, since we haven't learned this kind of quick way to do it yet. Let's practice what we learned at the end of the last section. Remember that it said the fastest way to do this is look at the first polynomial, the left one. Look at the very left term there. So I'm going to focus on him first, the x. Take him and multiply him by every term in the second polynomial. So I'll do that first. I'm going to write those guys. So I got the x times the x, that'll make x squared. The x times the 5 will make 5x. And that takes care of that first term in the first polynomial, x. Now I'll move on to the next term, the 6, and do the same thing. 6 times the x, and then 6 times the 5. So first 6 times x, that'll be 6x. And then 6 times 5 will be 30. Okay, that looks good. Now I see there are a few like terms, and that's all I really have left to do. X squared plus, 5x and 6x makes 11x. And then I have a 30 that's the constant term, that there's nothing for it to combine with. So there it is. Okay. Let's see, so that one is kind of an example of a problem that we could multiply with this kind of simpler method, or I guess it's not really a simpler method, it's more just a way to remember what to multiply. And this one you might have seen before. I don't know if you've seen multiplying polynomials before. I'm sure you've heard of this. This is called the FOIL method. So I guess think of it like tinfoil. That's what they mean, foil. But it's the F, the O, the I, the L, they mean something. So let's see, it's only for like it says, only for multiplying two binomials. So as soon as one of the polynomials you're multiplying has any number of terms other than 2, this won't work. It's only for if you have 2 terms times 2 terms, a binomial times a binomial. But you'll actually see that quite a bit, so don't get too sad where you say, oh my gosh, how often does that happen? It'll actually happen quite a bit in this class. So okay, it says if you're multiplying 2 binomials, so notice in the example we already did above where we didn't even know this method, if we multiplied everything out, we multiplied everything out. Notice that how many terms did we have before we combined like terms? We had 1, 2, 3, 4 terms, right? Okay, so they're saying the way you can find those terms quickly is to just think, okay, your first term, like it says, F stands for first. You're multiplying the first terms, which means you're multiplying the first times the first. So notice, let me see, I'm going to erase all this junk that I wrote here. Okay, the first term I got, the x squared, where did he come from? It came from the x, which was the first term in the first polynomial, times the other x, which was the first term in the first polynomial. So that's what they're saying, that the first term you're going to get when you multiply is just the first times the first, the x times the x, or whatever the terms are. So that's how you can think of, that's what the F in FOIL stands for. The second term we got was 5x, and where did that come from? That was the x in the front times the 5 at the end. So they're saying you're going to use an O to stand for that. That's the outer terms, which kind of makes sense, because if you think of this as one problem, what are your outer terms? The ones that are on the outside, x and 5. So you can think of that as, just the outer times the outer. The ones that are furthest apart, multiply those next. Okay, then the next term we got a 6x. Where did that come from? That was kind of actually like the inner term, sort of, right? The 6 and the x, those are the ones that are closest together. And that's exactly what the I stands for. The next term is going to be your inner terms, the inner times the inner. 6 times x made 6x. And then the very last term we got was what, 30. That one you can get by multiplying, where do we get that guy? The 6 times the 6 there. And the way they think of that is you're multiplying the last terms. So in the first binomial, the x plus 6, think of 6 as the last term. It's the furthest to the right, so he's last. And then the 5 in the second parentheses is the last term, because it was the furthest to the right. So that's the way you can just kind of memorize what you're supposed to multiply without really thinking that hard about distributing. Just think, okay, I have to have a FOIL. So what's the first term times the first term? In the above example, it's x times x, that's x squared. In the above example, next thing I want to do is multiply the two outer terms. The two outer guys are the furthest apart. The x times the 5, that makes 5x. And then the inner, I stands for inner. The inner terms are the two that are closest together. The 6 times the x, that makes 6x. And lastly, we have the last terms, the ones that are I guess the very right side of the parentheses. The 6 is on the right of the first parentheses times the 5 that's on the right of the second parentheses. Those multiply to make 30. And then from there, you're just kind of combining like terms. X squared plus, let's see, 5x and 6x makes 11x, and then the 30. So that's a different way to think of it. Instead of, I guess, worrying about, oh, what do I distribute first? Did I miss any terms? If you just kind of memorize first, outer, inner, last, then that might make these easier. But again, remember that this only works for a binomial times a binomial. If either of them have more terms or less terms than 2, then this won't work. All right, let's put this into practice. Then you can kind of decide, do you think this is worth memorizing, or do I just want to kind of do this the old-fashioned way? All right, let's see here. Let's try example 2, part A. So remember, I'm going to try to write, you don't have to write this. This is just kind of if you want to practice remembering what FOIL stands for. I think for all these problems, I'm going to write FOIL, so I remember, I'm prompting myself to multiply certain things together. FOIL, FOIL. All right, that sounds good. Let's see now. In the part A, I have, first thing I want to do is multiply f. Okay, f stands for first. The first term of the first polynomial is x. The first term of the second polynomial is also x. X times x makes x squared. So that's my f term, that first times first. All right, next is O. O stands for outer. The two outer terms are the x here and the 2 here. X times 2 makes 2x, and it's positive, so I'll put a plus. The next one, I, stands for inner. The inner terms are the negative 3 and the x, because they're closest together. Negative 3 times x is negative 3x. And then the last guy is the last term times the last term, which are the furthest to the right in each polynomial. Negative 3 times positive 2 is negative 6. There they are. So it's not less writing than what we did before, it's just maybe an easier way for you to memorize what to do. All right, what multiplies by what first, and then what? Just kind of remembering FOIL is good. First, outer, inner, last. And of course, if you're done and you look around and you see there are like terms, of course you want to combine them. It'll be x squared and then minus x when you combine like terms, and then minus 6. Okay, I think that looks good. Let's just practice the next one. And you can, yeah, like I said, you can decide if you like this method or you think it's kind of silly. Is it really worth memorizing? I think most people like it, so it's really worth memorizing. And even in your next math class, you'll hear people, or you'll hear your instructor, or you'll see people on the homework. If you watch the videos on the homework, they'll describe this process as FOIL. Like if they're given this thing and they multiply it out, they say, okay, let's FOIL this. So if you don't memorize this process, you'll probably still hear people talk about it. Just keep in mind, even if you don't memorize the process, remember what it means, FOIL. All right. So first thing we want to do is multiply the first times the first. That's the first term here times the first term there. M times 3m, that's 3m squared. Then we want O for outer. The outer terms are the m from the first parentheses times the negative 8 from the second. Those are the furthest apart. M times negative 8 is negative 8m. And then you have I for inner. The inner terms are the negative 7 in the first parentheses and the 3 in the second. Negative 7 times 3m is negative 21m. And then L stands for last. That's the negative 7 times the negative 8. Negative 7 times negative 8 is positive 56. There we go. And we're used to this. Most problems where you're multiplying two binomials, it seems like the first term has no like terms, neither does the last. But for the most part, the outer and the inner will be like terms, because they're both m's. So we have -8 and -21. That makes -29m. What a beautiful answer. Very nice. All right. So far, so good. Let's try part C here. What do we have? I'm going to first start with the first times the first. Here, the first and the first are the 6y squared and the 3y squared. Let's see. 6 times 3, that's 18. The y squared times the y squared, if I add the powers, I get y to the 4th. Okay, so far so good. And the outer times the outer terms are 6y squared and -2. 6y squared times -2, that's -12y squared. Alright, I think we're doing good here. And then I stands for inner, that's the two inner terms, the 5y and the 3y squared. 5y times 3y squared, that's 15. If you add the powers, 1 plus 2 is 3, so y to the 3rd power. And then the last times the last, that's 5y times -2. 5y times -2 is -10y. And this problem, notice there are no like terms. So in the last example when I said, oh, the outer and the inner are often like terms. Yeah, it's often, but not always. This one proves it. There are no like terms here, but I shouldn't leave my answer like this because remember, you want these in descending order of powers, and they're not quite there. Or in descending order of exponents, I should say. Powers, exponents, same thing. But alright, the highest exponent I see is a 4. I'll write that first. And then the 3rd power, so I better move him in front of the outer term. Okay, then the inner term has a y squared. He's next. The lowest power is a 1, so he'll go last. And there they are. And make sure, of course, you probably already know this, but just to be safe, make sure the sign moves with it. So if I switch the outer and the inner, make sure the negative or the subtraction sign follows the 12 and the positive sign follows the 15. Don't just switch the 12 and the 15, leaving the negative and the positive as they are. Think of the 12 and the negative as attached to each other, and the 15 and the positive as attached to each other. Okay, I think it looks good. So far, so good, you guys. Let's try... Oh yeah, in these problems, there's not really a way to check your answer, sadly. Not yet. In coming sections in the next chapter, we'll see that there is a way to check your answer on these. But for now, I'd say just multiply it over again. See if you get the same answer. I know that's not the best way to check, but for now, that's all we have. Alright, so part D, then we'll move on to the next type of tricky trick. Okay, we want to do first times first. The first terms are 2 and 4. That's pretty easy, right? 2 times 4 is 8. I can handle that one. And then you want the outer times the outer. That's the 2 times the -2x squared. 2 times -2x squared is -4x squared. Now we want the inner terms. That's the -7x times the 4. -7x times 4 is -28x. Alright, and then lastly, which is pretty fitting because it's called the last times the last. The last times the last is -7x times -2x squared. Well, I gotta be careful. It's a negative times a negative, so it's a positive. 7 times 2 is 14. X times x squared, if I add their powers, it's a 1 plus a 2, that's 3. Alright, I think we did all the multiplying right. Now it's just a matter of cleaning this up and writing it in the correct order. I see that the highest power is a 3. Even though he was at the end of this problem, I'm going to write him first. Because you want it to be highest power left and the lowest to the right. So I've got that one down. The next highest power is the square. I'll write him next, of course carrying his negative or subtraction sign along with it. And then the x term, 28x, carrying his negative or subtraction sign. The last guy is at 8, and he's positive, so I'll put a plus. There it is. Beautiful. Alright, so now I think you can probably decide if you like FOIL or not. It's kind of nice, then you don't have to worry about, oh, which one am I multiplying now? Did I already multiply these two together? I forget. As long as you remember first, outer, inner, last, then I don't think you'll ever forget how these go. Alright, so we're going to have another kind of trick here of how to multiply two binomials, but they're only specific types. But maybe just to get the theory behind it and why this trick or this thing that we could memorize will be nice, let's look at example 3 to see why this works. So multiply x plus 4, x minus 4. So kind of notice that those have the same terms, right? You have an x and an x. Those are both, the first and the first are the same term. the last and the last are the same term, 4 and 4. You just have opposite signs. So that's something that you want to kind of notice on this one. These binomials have the same terms. You don't have to write this out if you don't want, but if you want to, that's okay. These binomials have the same terms because you have an x and a 4 and a 4, but opposite signs in between. You know, one has a plus, one has a minus. So these ones are really special. Like, that's, I guess, the name of the section, right? Special products. But for now, let's pretend like we don't know that something special is going to happen. Let's just do the FOIL thing. Okay, I'll do FOIL here. And we'll see what we get. So first times first there is going to be x times x. That's x squared. I can handle that part. And then you have outer times outer. That's an x times a negative 4. That'll make negative 4x. The inner times the inner. That's positive 4 times x, which is plus 4x. And then the last times the last. That's positive 4 times negative 4. That's negative 16. And now if you look at this and you say, all right, let me combine like terms, notice the outer and the inner cancel. And that's when you have this type of problem, like we described up here, you have two binomials that have the same terms, but opposite signs. Like we have a plus and then a minus. If you switched it around and put a minus on the left and then a plus, it would be the same thing. But basically what happens is the outer and the inner terms will cancel each other and they'll disappear. It'll make it really nice. So really on this problem, all that's left is the first term, x squared, the last term, negative 16, or subtracting 16. And that'll always be true. So if you want, just to save yourself time on these problems, if you recognize that, let's say you come across a problem like this in the homework, you say, oh, those two binomials have the same terms, x and x, 4 and 4, but there's opposite signs in the middle. One has a plus, one has a minus. So you know what you can do is just say, I'm not even going to bother multiplying the outer and the inner, because I know they're going to cancel. Let me just focus on the first times the first, that's x squared, last times last, 16, bada bing, bada boom. And then you save yourself a little time. And if you kind of think, well, maybe that's kind of silly, does it really take that much more time to multiply the outer and the inner? You know, if you're thinking, is it really worth memorizing this little method here just to save, I don't know, 5 seconds of multiplying the outer and the inner? I don't know if it's really worth memorizing. This will be, just kind of seeing this and trying to memorize it, this will be useful in the next chapter. So maybe when you multiply these guys out, I don't know how useful this is. It doesn't take much more time to actually multiply the outer and the inner. But this will be definitely useful in the next chapter. So it's good to have seen and good to practice doing these, using this little tricky trick. Alright, but they kind of write it out. They're saying, in general, if you're multiplying two binomials like we had, the first terms are the same, notice a and a. They could be whatever. They could be a variable, they could be a number. The second terms are the same, b and b. And the same thing with those guys. They can be numbers, they can be variables, or a combination of the two, doesn't matter. But as long as you have the same terms, one with the plus, one with the minus, you'll end up just having the first times the first, and the last times the last. The outer and the inner cancel. And then similarly, what if you have the same thing, you just have the minus on the left, and the plus on the right. You just, switch the signs. Instead of a plus and then a minus, you have a minus then a plus. You end up with the same thing. It doesn't really matter if the minus is first and then the plus, or vice versa. You're going to still get first times first, last times last, outer and inner cancel. Outer and inner cancel, so don't even multiply them. Yeah, that's kind of the idea here. Don't waste your time multiplying them, because they're going to cancel anyway. Alright, so keep that in mind. Let's try these next couple examples trying to use this little trick here. So example 4 part A, what do we have there? I'm just going to check to make sure these are the types that I'm looking at. You notice that the first term and the first term are the same. Okay, A and A, so far so good. The second terms are the same, right? 3 and 3. And these do have opposite signs. One has a minus, one has a plus in the middle. So this is the perfect type of problem to try to do this. So I'm just going to say, instead of writing FOIL, F-O-I-L, I'm just going to do first and last because I know the outer and the inner are going to cancel. So I'll just focus on what's the first guy times the first guy. A times A, that's A squared. And then outer and inner, don't even worry about them, they're going to cancel. Last times last, negative 3 times positive 3 is negative 9. And that's it. You could have done the FOIL thing, but if you think about it, what would the outer and the inner be? It'd be a 3a and a negative 3a. Of course those are going to cancel. Come on. That's crazy talk. So don't waste your time on these ones anyway. But if you don't see this happening where it's the same two terms, opposite signs, you cannot do this. In other problems, like, let's see, what's the previous example we did way in the previous page? Like these examples here, example 2, parts A through D, you could not use this method because you notice none of these have the same terms. Like in part A, yeah, the x's are the same, but then you have a 3 and a 2. Those aren't the same numbers. So in these ones, you really do have to write out the inner and the outer. It's only if they have the exact same terms, opposite signs like we see in these problems, that you can use this method where you skip the outer and the inner. Okay, let's try the next one. But I'm going to practice just checking to make sure I can actually use this. So notice the first terms are the same, 5 and 5. Okay, so far so good. And then the last terms, 6z, 6z, those are the same. Not only that though, then you have opposite signs in the middle, a plus and a minus. Okay, just making sure I can actually do this method. If any of those things weren't happening, like if those were both a plus or both a minus, I couldn't do this. Or if one of the terms was not exactly the same as the one in the previous polynomial, then you couldn't do this. But this one checks out, so I'm going to just say, alright, it's going to be first times first, which is 5 times 5, that's 25. The last times the last, that's the 6z times the negative 6z, that's a negative 36z squared, since you're adding the powers. 1 plus 1 is 2. So there he is, 25 minus 36z squared, although, like we've seen, you want to write that in descending order of powers, so I'm going to write the negative 36z squared and then the 25. Just because, yeah, they like to see the highest power and then the lower power. Alright, let's try the next one here. Just making sure it's one of those types. I do see the first terms are the same, 2t squared, 2t squared. That's exactly the same. The second term, 7 and 7, those are the same. And the signs in between are opposite. The first one has a minus, the second one has a plus. Alright, then I'm able to use this method. The first times the first, 2t squared times 2t squared. That's 4t to the 4th. Then the last times the last, that's a negative 7 times a positive 7, negative 49. There he is. That's a beautiful, beautiful polynomial, and I do have it in descending order of powers. T to the 4th comes before the constant, because you can think of the constant as having a power of 0. Alright, let's move on. There's only one more method here. This one, I'd say this one, I don't know if I would... This is probably... I know I shouldn't say this. This is the least useful one, I think. But if you want to memorize it, it's okay. I don't know. See how you feel. This one, I think when I was a student, I didn't bother memorizing this one. It kind of helps you in the next chapter, but I don't think... It's just easier to relearn it in the next chapter. This is just not really worth memorizing. But I'll leave it up to you. That's my opinion, but see how you feel. Don't tell anyone I said that. That's like blasphemy probably in the math community, right? Alright, so example 5, this will kind of lead us into this trick here. So it's saying use the FOIL method to multiply. You have x minus 6 to the second power, and at first you look at that guy and you say, what? There's nothing to multiply. How am I going to use FOIL? Okay, so remember the exponent rules. There was one rule where you have, if you have a times b to some power, then you can distribute that power, right? It'd be like a to the n, b to the n, something like that. That was a rule, but then we said if there was a plus in the middle, instead of multiplying, like that one right there is multiplying a times b, but if it was a plus b or a minus b, you cannot distribute that n power. So I'm going to say that is not equal to a to the n plus b to the n. There was no exponent rule like that. We didn't mention anything about things adding inside parentheses. So there's not, you cannot distribute that second power. So it's an exponent is not like let's say you had 2, it was like x minus 6 times 2. Then you can multiply, or you can distribute the 2 because you're multiplying them. If you have an exponent, you cannot distribute that exponent, unfortunately. Cannot distribute the exponent. I remember one professor I have, he said, if people try to distribute that exponent, they call that the freshman's dream or something, I guess, because a lot of college freshmen, your first year, you want to do that. But then once you take one or two math classes, you realize, dang it, I can't do that. But don't feel bad. If you want to do that, or you ever accidentally do that, forgetting, don't feel bad. People in my calculus class do that. They forget that I can't do that. Alright, but what we have to do, unfortunately, is think of x minus 6 squared. It's like, what does it mean to square something? Well, if you square something, that means multiply that thing by itself twice, right? So that really means x minus 6 times itself. And then we'll have to FOIL that, because notice that's a binomial times a binomial. And at first I was getting all excited. I said, oh wait, can I use that trick like in the last example? Because look, the terms are the same, right? You have an x and an x, okay, same terms, 6 and a 6, but the signs in between are not opposites. It should be a plus and a minus, or a minus and a plus. Since they're both minuses, I can't use the trick that I used before, where I just do the first times the first and the last times the last. Alright, so unfortunately I do actually have to FOIL this out. I'll do first times first, then outer times outer, then inner times inner, then last times last. And we'll see if there are any like terms there. So okay, we got x times x, that's x squared. That's the first times the first. The outer times the outer, x times negative 6 makes negative 6x. The inner times the inner, negative 6 times x is another negative 6x. Then the last times the last, negative 6 times negative 6 is positive 36. Alright, and then I see there are a couple like terms there. The first guy has no like term, x squared, but the negative 6x and the negative 6x make negative 12x. And then the last term, 36, has no like term. So okay, that's my result there, x squared minus 12x plus 36. There he is. So okay, I'm going to erase this here, sorry, to get more room to kind of talk about what we're going to talk about now. So, alright, so I guess the idea behind this is notice, what did our answer look like? It was x squared. Okay, that sounds good. Okay, where did x squared come from? That was the first times the first, kind of like x times itself or something like that. How about the middle guy though? It was negative 12x. So where does negative 12 come from? I guess the idea is, if you're looking at the original problem, it was x minus 6 squared. Negative 12 is, I guess, like you're doubling the negative 6 that was in the parentheses to begin with. So I guess I could have jumped to the end result if I said, okay, what's this guy doubled? Negative 6 doubled is negative 12. And that could have gotten me to the very end of this problem. And then the last guy, 36, was our third term. You could say, okay, where'd he come from? Well, that was the second term that we started with, 6 times itself. 6 times 6 is 36. Okay, so this method is kind of complicated, but let's see what it says here. So they're saying if you have a binomial squared, let's say a plus b, who knows what those are, it's going to end up, if you FOIL it out and you combine like terms, at the very end, after you FOIL and combine like terms, the first term you'll have is a squared, so it's really just the first term in this binomial squared. The second term will be, okay, a times b, so the two terms in your binomial, a, b, doubled, so 2 times a times b. And then your last term will be b squared, the second term in your binomial. So it's kind of complicated. And then if you had a minus in between the two terms to begin with, like we had in this example, notice it was x minus 6. So it's going to look the same, except the middle sign will be a negative, like we saw in ours. It was a positive, a negative, and then a positive. So see, yeah, this is a very complicated method, and I don't know if it's, to me, I don't know if it's really worth memorizing. It's going to be up to you. We'll try to use it, though, here to see how you feel. Okay, in example 6, there's 3 parts here, and we'll try this method for all 3 parts. But just remember that in example 6, you could just write these all out. Like, okay, I'm going to write it down here. This is an alternately. Example 6 here, we have, so part A. This is for if you think this method's kind of silly and it's not worth memorizing. You could say, okay, you're starting with m plus 5 squared. Well, I know what something squared means. It means multiply this thing by itself twice. And then I'll FOIL it out. First times first, outer times inner, outer times outer, etc., etc. Just FOIL it out. That's your, I guess, kind of, it takes a little longer than the method that we're going to use, but it's easy to remember, I guess. And then for part B, you could do the same thing, 1 minus 4x squared. That means you're multiplying 1 minus 4x times itself. And from there, I'll do the FOIL. First times first, outer times outer, inner times inner, last times last. And then you'll combine like terms and you'll be done. And then the same with the last guy. It's 2y cubed plus 3 squared. When you're squaring something, that really means that thing times itself. So I'll write what's in parentheses twice. And then FOIL. First times first, outer times outer, inner times inner, last times last. So this is your alternative way that takes a little longer, but it's less memorizing. So I'd say whether you memorize this method or not depends how good a memory you have. I think I have a bad memory, so I probably don't bother memorizing it But if you have a good memory with extra room in it, you're like, I have plenty of room in my memory for something new, I might as well memorize this and save myself some time. But if you're not in that boat where you say, man, my memory is already taken up with so much crap, okay, then I guess I just do it this long way here. But okay, we'll try our best. Let's see. So looking at part A, we'll try to do this the tricky trick way. I see it's m plus 5 squared. That kind of matches this top one here more because there's a plus in between. If it was m minus 5 squared, I'd use the bottom one. But okay, so what I have now, it looks like the left side. It's something plus something squared, but the result will be the right side. So I think what I'll do is I'm going to write that out. It's going to be a squared plus 2ab plus b squared. I just have to decide what's my a, what's my b here. On this specific example, a is your first term in the parentheses, so my a is an m, and b is supposed to be the second term in the parentheses, which is 5 for us. So all I have to do is take this expression here, replace the a with m and the b with 5. So okay, a is m, I'm going to rewrite that guy. B is 5, where do I see b's here? But I'm keeping everything else the same. There's a square on the a, there's a 2 in front of ab, and then there's a square on the b. Hopefully that makes sense. So notice, we just identified what a and b are. A and b are just kind of generic terms for what's the first thing in the parentheses? Okay, that's a. What's the second thing in parentheses? That's b. So I just identified what's a, what's b. And then in this kind of little formula here, a squared plus 2ab plus b squared, I just replaced a with m and b with 5. So here's a was m, so a squared is m squared. 2ab is 2 times m times 5. And then b squared is 5 squared. And then we'll just simplify that. So the first guy, m squared, I mean, you don't really need parentheses, but you never know. It's good to write just in case. And in the middle term, it's 2 times m times 5. Well, you could do 2 times 5 is 10, and then there's an m attached. And then the last guy, 5 squared, is 25. There it is, okay. Looks good. So it took a while, but the more of these you try with this method, the better you'll get at it. But an alternative would be, like I said, maybe you can compare if you want. You could have just written m plus 5 twice and FOILed. So I go m times m, okay, that's m squared. Then the outer times the outer, that's m times 5, 5m. The inner times the inner is another 5m. Then the last times the last, 5 times 5 is 25. And now I'll combine like terms. The two inner terms, 5m and 5m, make 10m. So I don't know if that took a lot longer than the method that we learned, right? I don't know if one had more thinking involved. This one maybe took one extra step or something because I had to combine like terms, but I don't know if the above method was way faster or easier, huh? Oh well. Maybe we'll try to make this quicker here, just to show why this method is nice. So keeping it general, I'm thinking in part B there's a minus in the middle, so I'm going to have my answer look more like this guy here. It's going to be a squared minus 2 times a times b plus b squared. Just kind of rewriting this guy, but where a and b are missing. And remember, a is the first term in the parentheses, and if I look in my parentheses, I have a 1 as my first term. B is what's in the second parentheses, or sorry, the second thing in parentheses. Mine's a 4x. And you don't need to write negative 4x, because the negative is already taken care of, with these signs here. So this guy, negative, the fact that this is a negative here and this is a positive here, it's already been taken into account that there's a negative in the middle. So don't feel like you have to include that as part of your B. And then I'll just fill in what I know. This is supposed to be an a squared here, but I have a 1 instead of an a. And then it's supposed to be minus 2 times a, which is 1, b, which is 4x. And lastly, plus b squared, but I have a 4x there. So 4x squared. And then let's simplify this guy. We got 1, and okay, 2 times 1 is 2. 2 times 4x is 8x. Then you have 4x squared, so be careful. This is where, since it's 4 times x, this is where you can distribute the square. It'll be 4 squared x squared. So you can only distribute a square if the things inside the parentheses are multiplying or dividing, not adding or subtracting. And then from there, I have to write these in descending order of powers. This guy has the highest power. And I might as well go 4 squared is 4 times 4, that's 16. X squared, and the next highest power is the 8x, and then the 1. So I kind of had to turn everything around and rewrite it. And maybe we could try that the long way just to show, yeah, then you can kind of compare apples to apples. Do I really like this method better, or Do I think it's kind of silly, or do I think it's a lot faster? So let's try that guy with this method, where you just take 1 minus 4x squared, rewrite it as that thing multiplied by itself in FOIL. So there, the first times the first, that's 1 times 1, which is 1. The outer times the outer, 1 times negative 4x is negative 4x. The inner times the inner, negative 4x times 1 is another negative 4x. The last times the last, okay, be careful. It's a negative 4x times a negative 4x, that's a positive 16x squared. Then I'll write that from highest power, 16x squared, to lowest power. The next one would be the x power, x to the 1, but there are two like terms, negative 4x and negative 4x make negative 8x, and then you have the 1 there. Let's say it's debatable which one of these is faster or easier, huh? I don't know, it's up to you. So you don't have to do it this fast, you know, the quote-unquote fast method that they show you, but, it's up to you. Alright, let's try this last one here. You got 2y to the third plus 3 squared. So I'm going to try to set it up the way they want us to. And notice, since there's a plus in the middle, it'll look more like... Here, this is getting a little messy here, huh? Let me erase all this stuff. Sorry about that. But the part C has a plus in the middle, so I'm focusing more on the top one, because that's what the result will look like if you have a plus between the two terms. So it's going to be some a squared, and I'm going to kind of figure out what a is later, plus 2 times a times b, I'll figure out what those are, plus b squared. Just kind of copying this thing that I have up here. This is kind of the formula for your end result of this problem. And then I'll identify what a and b are. And this could be just done in your head if you just want to think, oh, what's a? You don't have to write it out, a equals blah. A is the first term of this binomial, which is the first thing in the parentheses, 2y cubed. And then b is what's the second thing in the parentheses, it's 3. So I'll fill the a and the b in where they're supposed to go in this little formula here. It's supposed to be a squared first, that's 2y cubed, and then squared, plus 2 times a, which is 2y cubed, times b, which is 3, and then plus b squared, that would be 3 squared. And all I have to do is simplify this guy. And then this is another one of those times where I have a power on two things multiplying, so I'll have to distribute that power. It'll become 2 squared, and then I gotta be careful, it's y to the third squared, because y already had a power of 3, now I'm giving it another power of 2. I'll figure out what that is in a second. Now I'm multiplying all three of these together. Let's see, 2 times 2y cubed, that'll be 4y cubed. 4y cubed times 3 is 12y cubed. The middle term's not so bad. The last guy's not so bad either. 3 squared is 9. So I just got to think about this guy here. That's 2 squared is 4. Y to the third to the second power. Remember, if you have one base and two exponents, that's when you want to multiply their exponents. So it'll be y to the third. 3 times 2 is 6. 6th power. And I'll copy the other guys. And these are already in descending order of power, so I can just leave it as is. Alright, but then maybe, again, if you want to really compare apples to apples, you want to say, alright, let's see how that method stacks up to just kind of the old-fashioned, just the method where you just do it, I don't know, the simpler way or the obvious way. So 2y to the third plus 3 squared. All you have to do is remember, what does it mean to square something? It means to multiply that thing by itself. That's it. And then you say, oh look, that's a binomial times a binomial. I'll FOIL that out. The first times the first, 2y cubed times 2y cubed, that'll be 4y to the 6th. And the outer times the outer, that's 2y cubed times 3, that's 6y cubed. The inner is going to be the same thing, right? That's how these go. If you're squaring a binomial like we have, a binomial squared, the outer and the inner will be the same terms. So they won't cancel, but they will be like terms. So the inner times the inner, 3 times 2y cubed, that's 6y cubed, another one. And then the last times the last, 3 times 3 is 9. And all that's left to do is combine the two middle terms. So 4y to the 6 plus, 6 plus 6 is 12y to the third plus 9. So we got the same answer we did above, it's just, I don't know, this is probably the more intuitive method. It may take a little longer, a couple more steps, but I don't know, it's not too much worse, and it's less memorizing. So like I said, if you have a bad memory, or you think you have a bad memory, it's probably a better method, the bottom one. But this is probably useful if you, I don't know, if you like math and you have a good memory, it's probably a good way to go. Alright, well, I'll see you in the next section where we're going to divide polynomials. That's kind of fun. So I'll see you there. Thanks for listening. Have a good day.